Okay. Well, we'll just get started. As most of you know, we're launching the LGate 360 Control, Connect, and Extend 2.0 models pretty soon, probably within the next 2 weeks. So I wanted to go through some of the major changes here. I think the phrase I've used a lot is it's more of an evolution than a revolution. And what that means is most of the components inside the enclosure are the same. There are some quality of life improvements and things we've needed to do on the electrical side to make this fill you well with some of the changes that we've done. But overall, not much different in terms of the function. There are just some additional steps and things you should be aware of when troubleshooting this equipment and quoting this equipment out. So let me go ahead and share my screen here. I'm actually going to go through a unit on my desk. So can everyone see the LGate 360?
Yes. Yeah, can see it.
Great. So this is one fresh from DST. Should pretty much be the final form of the units that we ship to customers. One of the things that you'll notice right away is that we have a different power supply here. So as many of you know, we've had some issues in terms of the robustness of the Schneider power supply. We've had a lot of DOA, dead on arrival units. We've had units fail after commissioning, and we've communicated these issues to Schneider. Haven't had great feedback in terms of next steps to solve the problem, so we've decided to move away from Schneider entirely. DST's recommended this Delta Click 2 model line, which is great if they have great experience with it. All power supplies on paper look pretty much the same. So anecdotally, it's really helpful to know that they haven't seen any kind of failures from Delta like they've seen from Schneider. So because of the power supply change, we've had to modify some things inside the enclosure. So right away, you'll notice that this particular unit only has one AC breaker at the bottom. So unlike the LGate 360 that we've always shipped that has two breakers, regardless of us having high voltage or low voltage coming into the panel, when we were using Delta, we actually need to specify if we're using the low voltage power supply, which operates off of 120 volts AC, or if we're using the quote unquote high voltage option. For the sales guys, as you guys know, there's a special line item to opt for the high voltage option, and that will actually work technically from anywhere between 150 and I think 550 volts AC. So pretty much if you're looking to use 120, use this option. For anything else, you're going to use the high voltage option.
Hey, Danny, real quick, just a quick question for you. You might not have an answer. I'm just curious, like, what do you guys expect, or if any of those other sales guys know, or anyone with more experience, like designing projects, of the, like, what's the percentage likelihood of a project being high voltage versus low voltage? Like, I've been seeing most high voltage. I guess that's looking at larger ground mounts. Is there like kind of, do you have a sense of that at all?
Yeah, I know we discussed this a few months ago. Most of the smaller sites that are operating off of 208, 120 will have a low voltage option, be a pretty good fit. The very large, or I should say large community solar to utility size projects will typically have a control, a power, control power panel just for the DAS. So in those cases, 120 is very common. It's kind of that middle road where we have like a 480, 277 system, where you might not actually have a great option for pulling 120 volt AC. So basically, I would say it could be as high as half and half, Jeff. Looking at our previous year where we did a lot of utility scale projects, I would have been very confident that almost every single job would have 120, but I know that's definitely not the case this year. So we definitely will see both options. If for whatever reason we find that we're selling much more high voltage units than low voltage, we could potentially make that the standard offering. But for right now, it makes it a lot easier for us to just have the 120 volt AC option be available. and just make sure it's communicated well, that it only operates off of 120 volt AC. And what that means is there's one hot leg here, which is going to this AC breaker, and then we always have a neutral coming through. Okay, so I'm going to turn on the unit now, flip the AC breaker in the on position where you see red, no different than the original unit. And you'll see, I don't know if it's clear enough, that we have the DC OK light be on, and then you can start to see some of the components be powered up. Now, there is another step involved, especially when you're taking this unit out of the panel and hooking it up for the first time. There's actually a DC breaker in the design now. And the reason for that is because we have a lot more power going into this panel than before, and the sales guys will probably benefit from that eventually when we could say, hey, we can actually add more devices externally fairly safely. But because of the higher amperage or the higher power, we actually need to add a DC breaker. So when you get this out of the box, the DC breaker is in the off position, meaning that the button is up. So when you flip the breaker down here, the AC breaker, nothing happens. You'll see that, it looks like we have DC OK being on. And if you guys can't see that, trust me, that green light is on. But you need to still push the breaker in. You'll hear a click for everything to start powering up. Okay. Any questions on that? Okay, great. The other Delta power supply, the high voltage option, does look different. It'll be part of our manual, but it can distribute a spec sheet separately. It's a little bit rounder. It actually comes out a little bit more. But it's very similar in function, and we also have the DC breaker for that. The one difference you'll see in terms of the installer's point of view is obviously we'll have a high voltage option available, so you're going to need to have 2 hot legs. So there's going to be a 2-pole breaker just like we do with the 360 now. Okay. The Aqua Suite hasn't changed, so I won't go over that again. The other sort of quality of life improvement is this new Digi WR31 modem. Now, if you're familiar with troubleshooting the Digi WR21, it's really not much different in terms of your access or the LED light behavior, but the LED lights are a lot more visible on this unit, so no longer do you need to have the installer look underneath, especially if it's dark. It's a lot easier for them to just say, hey, if it's right here, they can see right away. If there's a lot of sun, they can cup it like that, but it's a lot easier than trying to peer underneath the WR21, which was kind of mounted horizontally. The actual Ethernet ports are also super accessible. There's some additional options here for serial. You'll see this DB9 connector and this kind of terminal block. Just ignore those entirely. We don't use them as part of our design. They're not options for troubleshooting or anything like that. So you can definitely just pretend they're not there. But we do have a nice USB port that's available, just like on the WR21, in the event that we need to do any firmware updates in the field or configuration changes in the field. That's a lot easier to deal with than, again, having the USB port be accessible underneath the unit. Okay. The other change regarding the cell modem that I wanted to cover is, if you look at the top now, you'll notice that there are 2 lines going from the modem to the top of the enclosure. So if you're familiar with sort of the nubby antenna that we had on the previous LGate, we only had one single antenna connection at the top that was just screwed on. Now we actually have 2. So if I can try to adjust the angle here a little bit, I can try to show you. The units actually come with these antennas. So they're a little bit longer than the nubby ones. But the nice thing is they just screw on top. Okay, so very similar to the old design, but with cellular LTE, where we want to have a primary and a secondary antenna for a lot of applications, especially as the 3G network starts to get deprecated, we're going to get better results with 2 antennas. So there's a little bit of a cost adder with that, but in terms of troubleshooting and commissioning, it should make things a lot smoother.
Are those the same bulkhead adapters? Or
great question. So, Sean, they are different. And the reason for that is we're going for a design that allows us to be a lot more flexible in terms of the actual units. So it's not...
Okay, so we can't use the old antenna as a backup. It just won't work.
Right. So you don't want to use the old antenna. If you guys have seen the old antenna, this piece is a lot wider. This type of connector is called a TNO type connector, and this is an N-type cable. And so it's very compatible with a lot of different antennas. Now, I don't have one here, but we will be offering another extended antenna option that has about a 10-meter length, which actually will screw to the same bulkheads and then can be attached to a wall or a pole. And basically, in terms of the actual wiring inside the panel, we don't need to worry about any changes. With the previous version, we needed to, unscrew this, screw in a wire here. This is an SMA type connector, so we used to have an SMA type antenna, route it through the bottom of the enclosure and eventually stick it on top here with the magnetized unit, or have it be mounted somewhere else. So this is a much better system.
So now if they want to put on the extended antenna, technically they don't even have to open the enclosure anymore.
Exactly right. Yep. Okay. Any other questions regarding the cellular hardware? Okay. If not, we'll move on. The other change you'll see that's fairly radical is we're using a different meter as an option. So this is the LCore Watson Mark II. I think we've already shipped a couple of these to the field, so some of the support folks may have already come across these. It's very similar to the Veris meter in terms of the form factor. Obviously, it fits quite nicely between the AquaSuit and the power supply still, but it's got a lot more flexibility in terms of CT options. Now, the sales folks will only use this LCore meter when we're using 5 amp CTs. Now, if folks don't know the difference between a 5 amp CT and the Veris millivolt CTs, all you really need to know is the 5 amp CTs are a little bit more standard and higher amperage type situations, especially utility scale projects, projects where the CTs aren't actually provided by Locus Energy, they're provided by the customer. We'll start to see and come across these a lot more. Has anybody had to work with 5 amp CTs before?
Yes.
Work with or click a button in Salesforce?
Actually work with.
Oh.
Okay. So, I mean, they're not much different. They could easily be confused. Typically, though, the millivolt CTs that we provide will be split core. So just like this guy that you're all familiar with, the output will actually say, I don't know if it's reversed, but it'll say 0.3 volts. It could even say 1 volt, but the actual size will be dictated by this volt. When we're looking at a 5 amp CT, it'll actually have a current ratio. So here we have a 5 amp CT. The label clearly says 800:5A. So if you guys are working in the field now, especially since, technically we can work with a millivolt CT or a 5 amp CT, we have for a while, but it's going to be even more prevalent now. You need to be aware that if things are not coming in as you expect, it's definitely worth checking the actual label. Obviously, the sales guys should be shipping the right CT, but it's good to know because there's a lot of other CTs floating around that the customer may have even provided themselves. One thing to note is it's very okay to connect a millivolt CT to an LCore meter. And it's definitely okay to connect a 5 amp CT to an LCore meter, but you definitely do not want to connect a 5 amp CT to a Veris meter. And the reason for that is that 5 amps is actually quite a lot of current, and the Veris meter will fry if you connect it and any kind of currents falling through it. So especially for support, if you have a customer who said, hey, I have the CT, it says 5 amps, and you know the LGate 360 build has a Varus. Well, watch out. That Varus might power on, but all the sort of measurement circuitry inside the meter will no longer work. So something to definitely be aware about. The other difference with 5 amp CTs is that because it's a lot more current and it's a lot more dangerous, there's some additional protections in place for this. So you'll notice that at the bottom here in the terminal block, we have a few of these orange tabs here. And so what that orange thing is called it's a shorting tab. So this is a little bit of a complex mechanism. It's not that hard once you work with it. So we'll have one in Louisville for you guys to play around with. Those in San Francisco, I'm sure we have something that is equivalent from our older days. But basically what this is doing is protecting the field technician or the electrician who's installing this equipment and making sure that if anything is terminated here, no current's actually going to flow inside the enclosure. So let me explain a little bit as to how that works. These actually pull out, so I can show you a little bit more closely. The very first thing you want to notice is there are 2 screws, and then there's this kind of orange bar here. If you look really closely inside, you'll see that there's these 2 metal prongs. Those 2 metal prongs don't go to anything right now. The orange tab connects the 2 of them, but they're not actually connected to anything electrically. Now, if I were to push this up, and these screws can actually screw down to make sure that that's fastened, anything that's flowing between these 2 prongs is now electrically connected. So if I insert this back into the actual terminal block and I have these CT lines here, let's say it's phase A, white and black, and the labels are pretty good on this one. So you'll see white and black, it's 1 row instead of the stack. So phase A would go here, white 1, and then black 4. And basically what that means is any kind of currents that might be flowing through the CT and eventually going through the CT leads, that is as if they were physically connected here. So it's a closed loop system. Now, that's actually not a problem for the CT. The CT has no resistance. So it's going to be a short, but basically, as long as that flow keeps happening, the CT is fine. So it's intended to be that way. So if for whatever reason the electrician is working in here, they would likely keep the shorting tab in the up position, and that's how it ships. Now, they could also electrically disconnect the top of the shorting block, I'm sorry, from the terminal block to the bottom by pulling this out. Now, that achieves the same safety, I suppose, in terms of no current flowing from the outside to the inside. But then what you have is these CT leads are not terminating anything. It's an open circuit. And you know, there are stories when you do this, basically what the CT does is it starts to shake. And it's not good. It'll start to break down mechanically. You'll obviously not have any measurements, and a lot of folks get confused about that. And it's obviously because there's no current flowing to the meter. So finally, the way it should be commissioned is you'll have this particular mechanism plugged in, and then you'll want to make sure that the shorting tab is in the down position. That allows us to have a closed loop between the CT and the actual meter here. So the meter will actually get measurements. Okay, so now that I have this disconnected, if I were to actually measure the resistance between the top and the bottom of the terminal block, I'll see that it's actually 0. Okay. Any questions on that?
Hey, Danny, quick question. With the 5 amp CTs, just remind me, are we only offering solid core, or are there split or flex or kind of rope CT options?
We have a lot of actually 5 amp CT options. We do have split core ones. We have quote unquote flex core. The troubleshooting of them is not much different than if you were to combine some of the split core troubleshooting from a millivolt CT to a 5 amp CT. So no differences there. Rope CTs or Rogowski coils are a totally different type of measuring device. so it's got nothing to do with 5 amps. So don't worry about that.
Okay. And is there any recommendation for the sales team? Obviously, split cores are easier to work with. Of like any reason that we should sell solid over split on the 5 amp side?
So usually you'll only really want to go for 5 amp solid core CTs if you're working in Massachusetts, and that's kind of part of the standard spec for CEC requirements there. So that's an easy way to quote out a project and know you have the basic requirements. The other application would be if we're not providing the CTs and someone else is providing them, especially if the customer knows they're getting them from the switchgear vendor. Those CTs are always 5 amps, so that's why you'll need an equivalent compatible 5 amp L-core meter. And the nice thing is we only sell the L-core model that's compatible with 5 amps. So if right now, if you were to spec the L-core watts on Mark II meter, you know it's definitely right for a 5 amp job. A good question. Before we get into the configuration of the L-core meter, just want to cover the terminal block. So in terms of the voltage reference, fuse holder, the voltage reference is identical to the Verus, so just a quick review. There's fuses in here. If you were to pull this out, there's not going to be any voltage reference. All of these come pre-installed, so no reason to really open that during installation. Still get phase A, phase B, phase C, and then there's actually going to be a separate neutral block. So that neutral is not required. If the neutral is not terminated, the L-core meter will actually automatically estimate a neutral value, but it's best to terminate it if possible. That could be totally different from the neutral used for control power. They could be the same, so there's flexibility there. If for whatever reason, you're getting this from a very different place electrically than where your CTs are, and you're running that, you'll definitely want to use the neutral in here for the meter and not for the control power. So that's really going to be up to the installer. They should know how to install CTs and VRFs, but it's just something to be aware of. If you don't see that, it's not necessarily a huge issue, but it's good for them to terminate if it's available. Okay. So you'll notice the L-core meter stays on regardless of whether or not I have this fuse holder open. So that's a slight difference from the Verus meter as well. The L-core meter is powered off of 24 volt DC. You'll notice that here. It's just coming off the power supply, just like the AquaSuite. So it's a good thing. I mean, if you wanted to power cycle the L-core meter for whatever reason, you can just push that DC breaker. It's actually kind of nice that it's here and handy. Not a big deal though. You can power cycle all this either from the DC breaker or the AC single pole breaker. Any questions around power and CT and VREF installs for the 360 2.0? Okay. We have our standard LGate and Ethernet options here. I don't think that's much different. It can definitely cover any questions that CLS has, perhaps, if those have been pain points in the past. The only thing I wanted to cover for this call, especially on the technical side, is the L-core's local configuration and display. So we'll have better documentation on this fairly shortly. DST will be configuring the L-core meters with all the new 2.0 units themselves. But just want to make everyone aware as to where you can find those settings, especially if you're troubleshooting communications. So can everyone see that local display, or is it a little bit washed out? Maybe I'll take out the tape here.
Barely, yeah.
How's that?
Oh, it was better before. There.
Looks pretty good.
Now we can't see it.
Really? Hang on.
It's the glare from your monitor screen.
It looks pretty good to me, so I'm gonna continue. I actually can't see it. I don't know what you guys are talking about. So if I were to press enter, you'll see the screen will line up, and we have the same directional buttons as the Verus pretty much. And whether LCOR took cues from Verus or, I mean, it's definitely not vice versa. Verus came first with this local display. I don't care. It's really nice. So press enter, and that's going to go to the menu. And there's really only, the only menu we really care about is configuration. So scroll down to the configuration option, press the arrow key, and then we only really care about these three settings: Modbus settings, current settings for current transformers, and then potential transformers. The Modbus settings, pretty self-explanatory. It'll give you some options for address, baud rate, and parity. Now be aware though, because these LCOR meters come with an option without the local display, there's kind of a weird thing where it might say address 1 on dial. And I think it's a little washed out right now, but if I were to make it a little darker, you guys will see 1 and then in parentheses on dial. What that means pretty much is it should not be like this from DST, but there is a dial here that allows you to set the Modbus address in kind of a manual way without touching the local display. So it's a little hard to see in the camera, but what I'm going to do basically is it's set to 1. There's kind of like a clock dial here. I'm going to set it to F, and what F allows me to do, I believe, is actually allow me to change the setting on the local display. So you'll see now that address now says 15. That on dial has gone away from the actual menu option. Do you guys see that now? Maybe no. A little too bright.
I can't see the right side of the blue screen. I can see address, baud rate, and parity, but there we go. 15, 9600, went away again. I think we get it. General idea.
Okay. So you can change it from 15 to 5, whatever. You just select it, and then you'll go down in the option. Baud rate should be 9600 BPS, and then parity should be none. So let me just make sure I scroll through. Those are all good. Stop bits is going to be 1, and everything else could be on its default. Delay is 0. All right, so really quickly, current transformers, if I were to go in here, you'll see that there's an option to change the phasing. Just leave it on identical CTs. And then for the CT ratio, there's 2 numbers here. You're only able to change the first number, and the second number is always going to be 1. Now, don't get confused. It's still compatible with 5 amp CTs. What LCOR is doing is just doing the math for you. So rather than setting it to X number to 1, it's going to set the same ratio, I'm sorry, X number to 5, it's going to set the same ratio to 1. So if I have a 500 to 5 amp CT, that would mean it's 100 to 1 CT. So I would go over here and change this to 100 and cycle through to change this to 0. Oh, hang on. That way. Okay. So, oh, actually, you do have the option to do either. So if whatever reason, you could do 100 to 1, or you could do 500 to 5. It's the same thing as far as the meter is concerned. It's just whatever your preference is. Okay. And again, that will be on the CT label, and it'll be on the sales order as well. But these should be configured from DST to begin with, unless the CTs are being provided by the installer, in which case they will have instructions on how to configure this in the field. The other thing that you might run into, but with very infrequently, is potential transformers. So basically, just like a CT is a current transformer that steps down the current from where you're measuring to something that you can actually have the meter look at. The PTs are taking a high voltage and bringing it down to a lower voltage that the meter can actually look at. And PTs, potential transformers, is pretty much what everyone's talking about when they're talking about a transformer anyway. So pretty much there's the PV system, there's a transformer in between just for the meter, and then the meter reads off directly from the transformer. But we need to know the ratio for that transformer. And let's say it's, I'm sorry, let me go back, scroll down. And let's just say it's 20-to-1. So you'll do the same thing. But again, this should be fairly rare. It should always be 1-to-1 on most systems.
And Danny, maybe this set of questioning is more appropriate for our pending meter training. But I was just wondering what voltage ranges are appropriate for this. And it sounds like PTs are always outside of our spec and that sort of thing. So is that a better for our kind of meter training, sounds like?
It could be. I mean, honestly, I wouldn't even look at the voltage rating. I would look at the size of the plant and make a call there. If you're measuring a point of interconnection that's greater than 1 or 2 megawatts, you may want to consider giving the client an SEL 735, just because there's a lot more options and troubleshooting if the site requires any kind of power quality meter. The L-Core meter, it's a good option, and technically it can measure anything that the SEL 735 can, assuming it's the same form factor. So it's got really nothing to do with voltage. In theory, you can use this for any site application, but in certain segments of the market, you might get a funny look if you try to spec out a Watts-on Mark II rather than an SEL 735. But from a technical electrical standpoint, it could do either.
Okay, because I've seen several kind of 1 to like below 5 megawatt projects that are asking us to meter on 12 kV medium voltage lanes.
Okay. So typically I would start with the SEL 735. Yeah, I would start with the 735, but if there's a discussion about a lower cost option, the L-Core Watts-on Mark II would work.
Okay, got it, tabled. Thanks.
Good question. Yep. With that said, I think that's basically everything I wanted to cover. But if folks have more questions, it's definitely not a bad format for it. So anybody have any questions on the engineering side, sales side, or support side on 2.0? I mean, basically the LGate Extend units, if it has a power supply, same things will apply here. We also will send an Extend with just an L-Core meter. So it's good that you guys know about that. The LGate Control has the same options as the 360. Nothing's really changing there. And the LGate Connect, really at the end of the day, the only thing that would change is, again, the power supply. So it's really good to know about how to troubleshoot that. But other than that, like I mentioned, it's really just a quality of life improvement. The other nice thing that the installers would appreciate is this DIN rail is flat on, I think, all of the units except for the LGate Extend and the 360. Which is a little bit tough to terminate things in. So that will be angled now for all of them. So just going to make installers a little bit happier, a little bit more cheery on the phone, but nothing for us to worry about in terms of troubleshooting.
I have a question about the deltas.
Yep.
Did I hear you correctly earlier that the quote-unquote high voltage will also accept 120 volt?
No, it can accept, it actually goes down to 155, so it won't work off.
Damn.
Yep. So even if, you're pulling one hot leg and a neutral from a high voltage system like a 480, 277, you cannot use the low voltage option. It's got to be 120 volts AC.
Right, but then you could also, did you also say that there are 2 inputs for the high voltage option and only 1 input for the low voltage, is that right?
That's right. Yep.
Okay, so like a 208 system could use either.
Right. Yeah, for 208
often,
system, you could use phase A and neutral for a low voltage option, or you can use phases A and B for a high voltage option.
Just gonna take some getting used to. Okay, cool.
Okay. Any other questions? So if these were to go in the field starting next week, everyone would feel pretty comfortable troubleshooting them?
Yeah,
okay.
looks good to me.
Great. Well, thanks
We have
everyone. Yep.
I was just going to ask if we have one of these Watson hooked up in our office.
Actually, Sean has one.
I'll check with
It might be
and see if we can get one. Just
there should be one in the
playing
office.
around with the interface would be helpful for CLS.
There is one. It's just I think misplaced. So,
Yeah.
Sean, if you're on the line,
Maybe eventually a demo unit for the office would be cool.
Sure. I mean, if you guys really need it for demos, I think we could probably part with this one, and you guys can share it between the two offices. Louisville has an LGate control for testing purposes and training, but I think this 360 doesn't necessarily need to live in any office, so happy to part with it if you guys need one. Okay. The one thing we're considering changing eventually, just to kind of give everyone a heads up, is the terminal block. We've gotten some feedback from installers that it's kind of difficult to terminate things and make sure that no stranded wire is touching anything because the plastic housing is actually a little separated from the inputs. So we're considering moving to a different terminal block, which is the Phoenix Contact one. And it's a little nicer. The inputs are a little bit more flush with the plastic housing, and there's actually options that we're looking into to have multiple lines terminated to them. But, you know, I think it's probably best we don't get into that on this call. We haven't made a decision there yet, so we'll definitely reschedule something or just send an email if that change is made. But on the sales side, that really shouldn't affect any of you guys. It's just more for the support folks and AEs. Okay, so great. I appreciate everyone's time. I know it's late on a Friday here on the East Coast. This is recorded. I'll put it online so you guys can take a look if there's anything I've missed. Definitely feel free to reach out and ask me any questions you may have. But otherwise, thanks again, and we'll be in touch. Bye, guys.
Thanks, Danny.
Thanks. Have a good weekend.